Today I will be talking about the second tutorial in the VARS-TOOL package, which is on sensitivity analysis of a real-world model. We will be running an exercise on the model HBV-SASK using the STAR-VARS method and looking over the VARS sensitivity indices such as total-variogram effects, IVARS, and Sobol total order effects. An example research question for this tutorial would be, suppose you have a hydrologic model with several uncertain parameters and you need to calibrate those parameters to fit model outputs to observe data. Which parameters are the most influential on quality of model fit to data? To answer this question, you can guide your focus on the calibration of those parameters that matter the most. First, we need to import the libraries. This includes VARS for sensitivity analysis and the model class for creating a wrapper around the desired model so that can be inputted into VARS. We can run the cells by pressing Shift-Enter, and something like this should happen with a star here. And once it's finished running, it will show a number. Now, while this is running, we will introduce the model. This is done by defining a function of interest in sensitivity analysis. Here, the following function runs the HBV-SASK model and returns a single model response. The model response here could be a flux or state variable at a given time step or goodness of fit performance metric. So I will run this cell and define the function. Next, we wrap the function of interest with the model class, shown here. Now we will give the wrapped function a quick test to make sure that it's outputting the correct response. And as you can see here, we got the right response. Next, we set up a VARS experiment. In the table below, we go over the attributes of the STAR-VARS algorithm. I will give you a few seconds to pause the video and read what each parameter does. Now we go to where we define the experiment. Here, you write the name of the program that you're wanting to run, and in this case, it is VARS, and you input each of its parameters to what you desire. Now we run the STAR-VARS. Now that the experiment is done running, we can see that the loading bars are complete here with each of the steps of the VARS program. Now we can take a look at some of the results. First thing we'll take a look at is IVARS, which stands for Integrated Variogram Across a Range of Scales. These are the primary sensitivity indices by the VARS approach. Here you can see the values printed, and next we can see a graph. 2 points to bring up about these graphs is we will be using VARS 50, which is the total variogram effect and is the most comprehensive sensitivity index. Point 2 is that we will also be plotting the sensitivity results in a log scale to help us better differentiate less influential parameters. Now if we take a look here at the different results, we can see that FRAC is definitely the most influential parameter. And when we take a look on the log scale, we can see that there are some other influential parameters as well. In addition to the IVARS indices, VARS estimates the Sobol variance-based total order effect as a side product. Below we can see the printed value for the Sobol total order effect, as well as the plot. As we can see, it is similar results to the IVARS indices. In addition to IVARS and Sobol, VARS estimates various versions of Morris derivative-based elementary effects as side products. This includes the mean absolute elementary effect, or ABE, and mean actual elementary effect, ACE. In the derivative-based approach, the user needs to choose a delta for numerical estimation of derivatives. It is recommended to go with the smallest delta available here, which is equal to delta H, but the user could choose any integer product of delta H as well. As you can see here, we choose a delta of interest equal to 0.1, which would be the minimum delta H. There are also some printed values of both the ABE and ACE values. Now we take a look at the graph for the mean absolute elementary effect and the mean actual elementary effect. As you can see, the results are similar to the previous two graphs that were shown. For advanced users of VARS, directional variograms may provide a wealth of information about the structure of the model response surface. It is noted that variograms are most meaningful when H is between 0 and 0.5 of the parameter ranges, but the user can also investigate the entire range of 0 to 1. Here we take a look at some of the variogram results printed, and now we take a look at the variogram plot. As you can see, as the perturbation scale gets larger, some of the parameters such as FRAC and PM get higher as the scale gets larger. And that is it for tutorial number 2.